Okay. So welcome everyone. So good to have you here again. This is our third physical event. You know, it sounds like 100 years ago we met like this, but it's actually only, I don't know, half a year. But it feels so good to see people again and talk to you. And actually we don't even need presentations because every time we gather 20 or 30 of you, you know, there's enough to talk about. And so it's okay. Anyway, so my name is Magnus Melander. You probably know me. I'm with Linda here, we're running things. And the Get on Top of events, this is number 29 actually. It was invented to make sure that people got to know what's just behind the corner. Because we thought that if everyone or as many as possible knows what's going on and they get on top of what's around the corner, it will give a little bit of a head start for us here in Sweden or where we are. And we have had many different themes. And today we start a new theme because now we believe 5G is just around the corner, finally. And that's why we do 5G today. We have changed the format a little bit. So instead of having a full room of people and nothing more, we have a small crowd in a big room for COVID reasons. And we film everything and we share it freely over YouTube on our internet channel. So we normally have, that's the way to share what we're going to talk about. The Get to Top of events are not about selling, it's about sharing. It's about, you know, that's how you get people on top. You share what you have learned so far. That's really the whole idea. And we are grateful for speakers who actually come here to share what they've actually learned so far. So with that, I'll start to introduce the first speaker who, funny enough, like a couple of the guys who signed up for the event, thought that this was obviously a digital meeting. So my friend Annie, he's actually in England, if I remember correctly. And I said, well, you have to do your speech anyway, because I want to listen to, I know you know a lot. So let's see if we can find Annie here. We also have another guy here who signed up, thinking that this was a digital meeting. And I know him very well, he's from England, and I think he's in England now. So I promised him that he can actually follow us on Zoom if possible. So it's Matt Hatton from one of the best analysts in IoT position you can imagine. So let's see. Annie? It's Annie. Well, here we go.
Good evening.
Do we hear you?
Yes, I can hear you very well and see you as well, both you and...
We need to find your sound, Annie. Do you hear me?
Yes, I can.
Yes. Oh, loud. I speak loud. Here to England.
Can you hear me now?
Yes.
I have friends who are trying to find the webcast as well.
There is no webcast.
No, it's not. Simple as that.
Tell them keep looking. Okay. Do we hear him?
Can you hear me?
Yes. Do you have to speak?
Matt can hear me on the bridge.
Okay. Take it away, Annie.
Okay, great. First, apologies for not being there in person. I'm actually not in London, but I'm not in Stockholm, despite what you see as the fake background on my Zoom bridge. This is our office in Solna, but I'm not in Solna. I'm actually in Norrtälje. I'm out of town for a couple of weeks, which is why I couldn't make it in person, and I didn't realize it was going to be held in person. That said, thank you very much for attending the event, and thanks Magnus and Linda for organizing this. Delighted to be here with you today. Without further ado, I'll just share my screen. The host seems to have disabled participant screen sharing. So Linda wasn't convinced that my slides were worth the bother.
I'm very selective. All right.
Okay, so here we go. Thanks. I believe I have somewhere slightly north of 15 minutes, so I'll try and keep this brief. I think I've met a lot of you in previous events hosted by Things. Today, what I thought as part of Get on Top of 5G is to kind of give you a state of the union on what we are seeing in terms of development in the enterprise and industrial private networks market, specifically as it relates to 5G. So my name's Aniruddho Basu, or Ani. I head up emerging business at a company called Mavenir. Mavenir is a US headquartered company. We are a fairly disruptive tech startup, not very young. We are about 15 years old, but essentially we play in the network space. I'll just kick this off with a reflection on a previous session we had last week together with Informa Telecoms, an analyst firm that you might be aware of, around private networks. And what we'd asked the participants, of whom there were about 150 or 200 odd, across the analyst community, the customer operator space, enterprise and industries, was while they registered was to kind of come up with what came to mind when they thought of private networks. And second, we'd actually come up with 3 questions that we'd asked them to pre-register with, and I'll come to that in a second. So what you see here is it's kind of representative of what people think across the ecosystem, from operators to enterprises to technology providers, the moment they hear the term private networks. The big central word, the big buzzword is security. And what really came up was also the elements of collaboration and ecosystem. And I'll reflect back on this to see if it jives with what the rest of the audience also feels when they think about private networks. This chart kind of shows you a reflection of what the audience or the registrants and participants felt on when it comes to private networks. Who did they feel would win the race, typically when it came to owning and managing and operating private both 4G and 5G networks? Did they believe that the majority of private networks will be deployed and owned by enterprises themselves or by mobile network operators? As you can see, the jury is still kind of out. There's by and large a 50-50 split, excluding the electoral college vote, based on the popular vote on whether it's going to be enterprise owned or operator owned. Then we'd also ask them to kind of reflect on, and this is fairly consistent with the analysts and the broader ecosystem at large, when will they really become a reality in terms of 5G? I'd say the majority of the participants felt that the big momentum, the big volume, the big uptake would come in the medium term, which is fairly consistent with our views on device availability, ecosystem maturity, and technology stability. But there's a fairly consistent view that there'll be at least a fifth felt that there'd be a short-term uptake of early experimentation around what private networks would bring. And then, of course, it would get into scaling effects and go on 3 years hence. Now, that being said, a quick bird's eye view on market trends. There's increasing amount of spectrum availability and regulatory approval and momentum around policymakers and governments. Specifically in the markets of US, Germany, UK, Japan, a lot of advanced markets across Northeast Asia, Europe, and North America, which have actually either awarded fully unlicensed or lightly licensed spectrum for use by enterprises. The US is currently fairly 4G centric when it comes to the CBRS spectrum. And they're still looking at private LTE deployments for small to medium businesses and typical mobile broadband kind of uptake. But interestingly, Germany, the UK, and Japan are very, very oriented around driving 5G adoption for advanced use cases, especially in the sub-6 gigahertz band. So there's going to be a variety of isolated, local, or shared spectrum usage patterns that are coming out. And fundamentally, a very new regulatory attitude that recognizes that enterprises have a very specific demand and need that needs to be addressed by actually allocating spectrum assets for their use. On the top right quadrant, it's also fairly evident that in the last, I'd say, 10 years since let's say 4G started getting into maturity and 5G was in its inception, there's a lot of new use cases around automated guided vehicles, AR, VR. There's a feeling that Wi-Fi and other access technologies are not fully adequate for things like advanced mobility, ultra-high broadband speeds, low latency requirements. And enterprises also kind of feel both from a business model perspective, the ask that they have around unique quality of service requirements around IoT, operational technologies, reliability, mobility, etc., is not really fulfilled with standard, let's say, lowest common denominator networks that are deployed by operators currently today. There's also a big amount of technology evolution, and I'll come back to this in terms of adding mission critical capabilities to the LTE stack with push-to-talk voice, VoIP kind of add-ons to a basic data layer. There's a road to 5G that's currently being paved that is really building on really specific feature sets on ultra reliable low latency networks and the ability to harness both licensed and unlicensed frequency bands. And essentially what I would say is 5G is also a point of inflection for the industry where both the IT and the telecoms world kind of coalesce together and start to adopt the resilience and vertical integrity and redundancies of the telecom side with more horizontalization, flexibility, agility, and cloudification, if you will, from the IT side. From our perspective, we also see that the whole ecosystem of ecosystems is going to be fairly critical in making sure that we are able to drive faster adoption of 3GPP based technologies in the enterprise and industry space. There's a lot of consortia, there's public-private partnerships that are involved, there's the triumvirate between academia, government, and private industry, and things I think is a very good representation of such a platform that connects different parts of the ecosystem together. There's a huge amount of emphasis, coming back to my word cloud from the start, on really making sure that there's deeply integrated and symbiotic relationships around a partner ecosystem going forward. I apologize for my throat, I've been talking all day. So what's the current state of the private networks market? If you look at the left, this is what we currently see in terms of the private networks activity by region. And this is not a vendor view. This is essentially an analyst view from Omdia or the Informa Telecoms group. By and large, I'd say North America and Western Europe are kind of really driving the big asks today, especially around CBRS-based private LTE networks in North America, coupled with sub-6 gigahertz 5G adoption and requirements coming out of Germany, UK, and parts of Western Europe. Close followers or advanced markets like Japan, Korea, and Taiwan in Asia Pacific, and then the rest of the world will follow. On the right, and this kind of ties in with the second chart I showed you in terms of adoption timeframes, the bulk of private networks activity that we see is essentially in the pre-commercial, pre-GA trial testbed kind of environment for 5G. There's close to half of the engagements, and that's something I can validate from a Mavenir standpoint, is essentially in the experimental stage. Then comes a lot of efforts around, followed with early network rollout and deployments. There's a big focus on alliance and sales partnerships, and then looking at advanced services and product launches and spectrum and policy activities, R&D, and so on. So big focus, at least in the near term and leading up to now, around trials and testbeds. There's definitely room for innovation and other deployment models. And this is kind of a survey that Omdia or Informa Telecoms had done across both 4G and 5G private networks from an enterprise standpoint. And this is normalized to 100. They essentially came to the conclusion that there's about slightly more than a third of enterprises actually prefer to own their own assets and have much higher degree of control over the network capabilities. They actually also look at, while owning the assets, they'll be operated by a third party. There's still, the jury's kind of still out in terms of preferences leaning towards purchase models. Will it be predominantly CapEx oriented? Are enterprises looking more from a consumption or a pay as you grow or a network as a service model? I think depending on which market we are currently looking at, I see Europe and the advanced industrial sector actually preferring right now to own network assets and more CapEx oriented businesses, because these would be very project specific kind of engagements. But the moment there is a higher degree of replication around similar kind of networks across hundreds or thousands of campuses or enterprises, for instance, with CBRS in the US, there is a more, let's say, preference, or at least an indication that people wouldn't mind consuming the network more as a service or a subscription model. So again, just to share with you folks that when it comes to technology, when it comes to ownership, when it comes to a question of whether it'll be operator run or enterprise owned, the jury and the audience and the ecosystem is kind of split down the middle. Now, from a technology standpoint, we definitely feel that the biggest development will be around the core network side, which is basically at the bottom, which needs to be able to support a multitude of both standards-based or 3GPP-based access technologies, but also be much more multi-access in terms of being able to embrace non-3GPP access, including fixed or Wi-Fi or NFC or even LPWAN or LoRa kind of technologies. The second part, that there's a lot of investment that's going on, and that's where the complexity also arises, is to manage the complicated underlying network, the OSS or the management layer, in order to drive higher degree of automation, service exposure, network exposure, network slicing. All of these elements are now being worked on to have a common seamless analytics and orchestration layer. When it comes to the radio access side on 3GPP, we definitely feel that LTE and 4G will have a long tail, primarily because it's a robust ecosystem. There's an established scale, there's spectrum availability, there's device availability, there's an established metric for performance in terms of cost per bit per throughput, for instance. At the same time, 5G brings with it certain capabilities that were not envisaged, keeping in mind operational technologies or industry grade requirements for use cases in mind. Things like ultra reliable low latency capabilities, very specific quality of service levels, a higher focus on positioning capabilities, spectrum flexibility that allows 5G technologies to address both sub-6 gigahertz spectrum bands as well as millimeter wave, network slicing, improved security abilities, new authentication methods. There's a whole host and a whole raft of embedded capabilities in the 5G stack, which has come about in the last, I would say, 7 to 8 years, or if not a little bit more, in close dialogue with not just 3GPP and the operator community and NGMN and organizations like this, but with organizations like Things, with organizations like 5G ACIA. A lot of industrial requirements and OT requirements have flown into the technology stack. So when it comes to industrial applications and operational technologies, forgive the jargon here, but ultra reliable low latency constructs or time sensitive networking or positioning or spectrum flexibility, all of these have also been identified by vertical requirements coming out of smart manufacturing, things that are needed for automated guided vehicles, machine vision, UHD, high availability distribution grids. So what you see on the bottom right is a raft of requirements that have come about and which have been seeded into the 3GPP releases and the whole build up of 5G capabilities over the last few years in close discussion and dialogue with potential users of the 5G network platform. Use cases, incidentally, I mean, and this is something you're already aware of. Fundamentally, everything from 2G or even 1G networks to 4G has been primarily oriented to cater for one basic or a couple of basic use cases, which is very consumer centric in terms of either voice or essentially internet connectivity or data access for mobile broadband subscribers. As we're already into 2020 and on the cusp of wider scale adoption of more complex technologies like 5G, the spectrum of use cases has really exploded. So on the one hand, you have mobile broadband enhanced kind of clusters, for enterprises or campus networks or stadia and other venues, which will prioritize high throughput, low latency, large data volumes. There's very specific use cases for things like offshore rigs or utility segments in terms of being extremely reliable, have extremely low latency and very high availability, for instance, even in healthcare. And then you have extremely high device densities, very specific support for industrial protocols that have existed for a number of decades, the need for edge computing, the need for very precise indoor positioning for manufacturing, automation, and the transport sector. Given this proliferation and very diverse set of use cases compared to traditional mobile broadband oriented towards consumers, there are agencies like, for instance, that I already mentioned, the 5G Alliance for Connected Industries and Automation, the 5G ACIA, which is looking at 3 quadrants of enhanced mobile broadband, massive MTC or machine type communication, and ultra reliable low latency communication, and then defining what requirements will feed into different releases for 5G. And as you can see, Mavenir is a member of 5G ACIA, together with some of the best and brightest from both the demand and the supply side of technology. There's increasing focus on PPP kind of platforms that are putting meaningful constructs in place for various partnerships to arise in the ecosystem. One such example is the Center for Connected Industries in Aachen, where there's work that is being done across mobile operators, across technology providers such as ourselves, across application and device vendors, and let's say industrial companies in the manufacturing, automotive, healthcare, et cetera sectors, where during the year constellations come together across members. They create minimum viable products and projects around specific use cases that will benefit from 5G capabilities. These are then deployed in live environments in those kind of companies, and then the whole idea is to scale and then proliferate and replicate these kind of projects over time. Now, I'll kind of wrap up with just a couple of charts. From a Mavenir standpoint, we of course would like, and this is more of a vision statement, being 15 years old, we really want to drive a step change in how innovation's done in terms of being able to foster innovation on top of the network stack. We want to be the industry's #1 provider of predominantly software-driven, cloud-powered, programmable network platforms. So if you think of what really caused the uplift and uptake of consumer connectivity, more than 7 billion mobile subscriptions today, was the fact that in 2007, a smartphone was launched by a little fruit company. But more importantly, what was launched on top of that platform, the whole App Store construct, which abstracted network complexity, exposed APIs for ecosystem and developers to create value and applications on top. I think for 5G, for private networks specifically, on top of a cloud-driven, edge-capable, slice-driven, multi-access 5G network, there needs to be a very robust, let's say, automation capability, which will make these networks much more self-aware, intelligent, a sort of a sentient and a more benign Skynet, if you will, in a Terminator reference. But more importantly, it needs to be able to expose the capabilities of the underlying network to industrial clients, to developers, tech companies, device vendors, to operators, to industry and government, so that it becomes sort of like an app store for industries and enterprises to really create value and drive momentum and adoption. So keeping in mind, I'll just conclude with not really a sales pitch. This is the translation of our network vision into reality. So on 5G, we have a lot of traction with projects already going on in places like Germany, in Taiwan, in Thailand, in Japan, in North America. We work very closely with device vendors, both on the chipset and the ODM side. We are working with web scale players like Google, Amazon, NTT, Oracle, etc., to even put parts of our network stack, including the radio, the RAN, and the data core functionality on private, public, and hybrid clouds. We are betting big on open architecture-based platforms because that's where we think the industry will be headed, to allow for underlying, not purpose-built, but data center hardware to not just run network functions, but to also run edge applications from application providers closer to the endpoints and devices to really accelerate low latency, high performance networks and applications and context-aware behavior in the networks. And then on top, as I explained, a seamless single pane of glass view on how to manage these complex networks in a good way with built-in and embedded capabilities around security, identity access management, and analytics. And then to have a digital enablement platform that exposes these capabilities to a broader ecosystem on top to kind of cater for and build an app store for industries and enterprises going forward. That was basically it. I'll send these charts out to Magnus and Linda, and they'll be published. I have with me my colleague here, Vinay, who's also based in Stockholm, who also couldn't make it today. Both of us are available. Our contact details are up here. We'd be happy to answer questions offline and reach out and connect with any of you that would like to discuss this further. Thank you very much. If there are any questions, I'll be happy to take those.
Thank you. I have no idea what to find you. I think you look here. Is that? Do you see me now?
Yes.
Great. Thank you. Do we have any questions for Anna before we go on? He's probably very tired. He's far away. Yeah, so have to please introduce yourself when you have a question.
Carl Fredrik Casting, and I'm working in WSI.
Do you hear that?
No, I don't. If you could repeat.
I will repeat it. Okay.
So I see a lot of industrial automation applications for this, but I only see companies from the IT, so to say, or the internet era in the slides. How do you see upon the Schneiders, the Siemens, all these guys working with the automation industry, believing that they have connected their products, they have models for 20 years?
My memory is not that long. So basically, he's from VSI, now Sigma these days. And he see a lot of internet companies and so forth, but where are the Schneiders and the industry? Do you deal with them, or where are they in your vision?
Yes. So, I mean, a lot of these industrial companies are actually part of driving the requirements on 5G standardization and capabilities. So if you look at the Schneider Electrics, if you look at the ABBs, etc., they're also members of 5G ACIA. They're members of, in many cases, things like the Center for Connected Industries. What the role we see for some of these companies is twofold. One of them would be as ecosystem, as customers, of course. They're looking to adopt 5G technologies and connectivity to automate their own factories, automate their own enterprises to drive operational efficiency with connectivity and data centricity. But at the same time, a lot of these companies are, let's say, very large potential go-to-market partners for us towards their segments. So for instance, in the healthcare side, I'll give you an example on smart connected buildings. Honeywell can both be a customer, but Honeywell is also a provider of connected buildings to real estate providers and enterprises. So Honeywell is also looking at taking in the technology and the 5G stack and taking it towards their eventual clients as well. So I'd say it's a mix of being both adopting the technology for themselves as well as proliferating them in terms of package service offerings towards their clients.
And I guess that's the whole change. We're talking about a real ecosystem that's to build around it, where people give and take and deliver and buy. We have time for one quick question and more, and then we leave you to it, Annie. No, we are fully educated. Thank you so much. And next time, read the invitation better, please.
I will. I'm missing the beer, so I'm missing out.
Yeah, you missed a lot. You missed the nice people who are here. So next time, take care.
Thank you very much, everyone. Take care.
Thank you. So, tänk på matte. It's a little bit complicated with people here and there. So that was it. It's complicated, it takes time, and it's online and da. Now let's go back to live. And our next speaker is Daniel Zetterlund from VSI/Sigma these days. Sigma Connectivity. Take it away.
Thank you. Yeah, I can try to be a slightly more brief than previous speaker. That was very advanced. Just short about WSI. We're a consulting company. We do devices of things in the IoT arena. And just of last Thursday, we actually got bought from Sigma Connectivity and can now, without lying, say that we are the most advanced 5G development house, design house in Europe. We have all the gears and we have all the people that we actually need now to build all the devices that's going to come into this ecosystem eventually. But being a device designer, our view of the 5G is slightly more simple. Okay. So 5G now and later, what are the essentials? I'm not going to go down to the deep side of it. I'm just going to talk about the brief explanation of what's now and what's next. We all see this, the blockchain and the 5G and the artificial intelligence. It's going to solve everything. And we got a problem for this, and it's going to be solved by AI. And we're talking, the self-driving cars and remote-controlled surgery and all the advanced things that's going to be out there. Sure, they're going to be there one day, eventually, in the future. There's no question about that, but it's not now. So 5G, it exists today. We have Tele2 just released the first version. We have Telia here, done some. So it's starting to roll slowly. Just briefly then, to explain where it spreads out also. This is the history. It started with the 2G, came up to the 3G, now we got 4G, and we are somewhere in this region where it's going to pass over and become 5G. And here branches out to become the low power ones, where we have Cat M1 and the narrowband IoT, and then we have the new radio. That's people are talking about, where we have all the crazy stuff. And so just to explain this further then, this is how simple that we see it. It's that 5G that we have now and going to have for the next couple of years is just a software version of the 4G, where you today can do plenty of the stuff that you're going to be able to do on the 5G. And then we have the new radio, where PTS is going to have the auction here within a month or so sometime, releasing the 3.7 gigahertz frequency sometime. So what will come out of that one, where you need new infrastructures, you need all the antennas and the whole thing just plain new, well, we'll see what happens with that. But that's when you're really going to start to get the advanced 5G systems coming. So, and this is pretty much how we've been seeing that it started to roll out. We have the fixed internet that Telia did the release for last year with Enskede got 5G installed in their homes. Certain houses could do that. So the fixed locations, where you're starting to see the mobile phones coming here this year-ish or early last year, sometimes with no real networks to have them for. Yeah, expanding into the more advanced stuff. And then we come into the low power, massive IoT part, where I think we're going to see most of the 5G things coming out, where you have the low power, the low cost, the high density. And then sometimes in the future, we're going to have the new radio. So the 4 pillars then, it's going to be the things, where you have the cat videos and the crazy stuff. And here you're going to have Samsungs, and it's going to be Apples, and it's going to be Googles, and all of those on mass volume type devices, where you're going to have the critical connected things in that part. And then we have the massive IoT, where you have all the cows and all the sensors and all the smart meterings and all of that coming up in a lot grander scale in terms of access points. What else was it to say about that? And here also the criticals, where we're talking private networks. What is critical? Is it going to be the 5Gs where you have your car running around my children? Well, that's one thing. Or if you have an open mine site where self-driving trucks, that's another. I heard from just last week that Komatsu has been doing this for quite some time. I think they have self-driving trucks for 13 years without an accident. But yes, sure, if you're in a mine site, you can do something totally different. So keeping track of that, what is the critical? It's also quite important. So two other words that has to be mentioned here if you're going to be on top of things. It's the sliced networks and the private networks. We just have Mavenir talking shortly about the private networks and all the capabilities that comes out of that. And then the sliced networks that hopefully Telia might gonna talk a little bit more about, where you slice the infrastructure that comes from the big operators for certain devices, where you can run it through and save that space for critical things. So your connected shirt doesn't interrupt the self-driving cars, making it more protected. That when it comes out as a service. The same thing here as what Mavenir just recently talked about, where you have the private networks, where you might have Telia slicing the networks into the factories. Here we're gonna have the smaller systems, the more local ones where you don't have to share space in terms of frequencies, etc. And here you have the hybrid. So here you can have the Telias and you have the Mavenirs down here with the dots and all the things that comes out of that one. And then you can have the mine sites, the drill sites, and if you're Volkswagen, for example, you more or less own the whole valley, perhaps Scania can do something like that. Then they can have the whole standalone dedicated spectrum for those type of products. So, and this is just important to remember, these are gonna come, and this is pretty much also where I think in the short term, you're gonna have the critical IoT coming. But the massive IoT, according to Ericsson, 52% of the cellular connectivity gonna be massive IoT. It's called today low power wide area networks, and you have the narrowbands IoT and your Cat M1. It's fully functioning today at Telia's networks on 4G, and it works fantastically good. We're running a few products as we speak on those, and results are great. This summer, I got my first smart metering on Telia's network for measuring my electricity. So those sensors are coming in that way too. And what 5G will do then is that increase the density with 500 times, so you can get more stuff on there. So whenever your connected shirts and your smart meter and all the different things comes in, it's going to leave space. And factory sites, pretty important, where you have massive dense areas where a lot of things are going on. You're going to have stadiums, shopping malls, maybe city centers. Rural areas going to do just fine with 4G forever. Especially also, if you look at 2G and 3G, they coexisted for what is it now, 30 years? Some 20 at least. 4G and 5G are going to be the same for quite a bit. But this is the most important though, and not to be forgotten. What will 5G do for your business? 4G Advanced will do everything you want to do today, but it's going to be a little slower and a little bit more expensive. But today we can see that we can make devices that cost 150 to 200 Swedish kronor with batteries and sensors and the modems, etc., up and running, functioning. That will come down slightly in the future. And the operator cost going to come down. Now we're at a few kronor per month. We can have roughly, well, 1 to 5 megabits, depending on if they're narrowband or Cat M1s. But the cost is low. It's going to be lower. We're talking about its internet connectivity going to be free someday, yeah, sure, and you pay it on another ways on the APIs and all the different service levels. But what I'm saying is you should start thinking about your business model. Took this. I don't have. We have any ABBs here? So this is an article from 2 weeks ago where we're starting the 5G networks. That's Telia together with ABB is there, and I think is Offri doing it together. But where he says that we have a long list of 5G ideas, everything, the dustbins and all the different stuff, up to the high-end sensitive systems. And when we connect all of this with the business system, that's when we have a real thinking smart factories. So co-working in these things, getting the massive IoT, cooperating with the critical devices. So you have the trackings and the smart meterings and the temperatures and whatnot. That is the massive IoT connected together with the robotics, where you can download your files and run it directly from the cloud, you know, somewhere, and just fast manufacturing. Well, sure, but it's the joint venture of it that makes the smart factory. So the mantra then, find the right problem or everything else would be too expensive. You know, if you're not solving anything, 1 krona can be expensive. So what's your problem? What is not connected or works just poorly? We have tons of Bluetooth connections out there with gateways and so on. It's not working. But then again, there's a big slice. We have Sigfox here today, you know, that's one slice of the pie, and we have the LoRa's, and we have the Bluetooth, and we have the Wi-Fi's. But this is pretty robust and a stable one. So whenever it's IT structural complicated, you don't want to run it through your IT systems. You can take it through Telia and directly to the cloud, which is not always possible. Or it's just not connected yet because it's too far away. It's just one sensor at that well somewhere measuring whatever, or in the forest or somewhere. We cannot build another infrastructure. You have the operators and they're great. And what data do you need in order to predict what happens? Here we come to the predictive maintenance. Just knowing, putting that up together and just have good analytics on it. And then you can start to predict what's coming next. Super important. Or, for example, then, if measuring electricity, for example, it's quite important to have good connectivity in order to know what you're going to invoice the customers. Previously, it used to be a guy coming out, I think. Wasn't it so in the past? Looking, writing it down, and then estimating that for the next coming months. I think my water bill is something similar still. The last one was something over the power lines, and you got some measurement over that one. So, and then the new one now is narrowband IoT, where you can have a reading every 15 minutes or something. So if your business model depends on invoicing according to what's actually used, you need a good connectivity. And that's where I think 5G is going to be very important. So this is actually my favorite slide then. So it's just talking about the whole ecosystem and all the different things. So the superpowers of a digital area. So if you have all the big ones you're looking at, we can look at the Klarna, they're in this range somewhere. We have Izettle coming up to that one. We have Husqvarna here today, not sponsoring the event a little bit. They're all over it. And then we have the bigger ones, you know, cloud starting with Google's and Amazon's, you know, they're going into the IT arena with their speakers and all the other devices. And we have sound industries, for example, is definitely in this range. And then we have the crazy Teslas, they're all over it. So super important not to forget any one of them and start small. You know, the AIs here, well, start thinking about it a little bit. What can you do with all the data? Because this is pretty much data generating devices. It's a thing, it's not important, but it's what you can do with the data using all the other applications, taking it out of that one. That is the most important thing. And that's where you should start looking at your business model. So wrap this up quickly. Evolving from 4G to 5G changes nothing. It's same thing, but still, then again, it changes everything. So, thank you.
Thank you. Thank you so much. I have a question for you.
Yes.
everybody talks about ecosystem when it talks, Annie loves to talk about that, for instance. So, and you are absolutely in the middle of that ecosystem. And you have been in the middle of the IoT ecosystem in Sweden. Probably if I have to single out one single company who being most important to the whole ecosystem is been BSI, who turn all those products into connected devices for large companies and small companies. Who talks to you?
Well, everybody talks to us.
Do everybody do that? Are you
In a sense,
without
in
you,
a
nothing
sense,
will happen?
In a way, everybody, or at least everybody should talk to us, but no, but
You get my
we're
point.
talking to many, and we are the device vendors, and we're starting from the bottom where we have to work our way up. We're using the Telias, but as just the piece of the puzzle. And then we're talking to the end customer who's going to be the product owner. So, yeah, so.
But this is kind of probably 1 to 3 years difference. If people like you are well taken care of ahead of time, maybe we get to an ecosystem and all of that pretty soon. But I'm not sure that happens, because when I talk to others like you, it's not necessarily very well dealt with by the vendors and the operators today. Is that right? Or am I wrong, maybe?
I'm not sure I understand your questions now.
Okay. Do you have to fight to get information and data and tools and kits and all of that? Or are people very actively trying to help you understand and get on top of how to develop the product now on 5G? So that's my question.
Well, yeah, that's a good question. Well, we can't dive too deep into all of this. We have to know the modems. They then in their turn, have all the experiences with how to work with the Ericssons and the Telias in order to set up the software in that one. But it's like if you buy a Tesla, you can't dive into every software stack in the whole of the car. You focus on the range of the batteries, the cost, and the colors, and a few other things. And that's where we as consultants have to be. We have to look at the key important things and then build out of the modules that are out there. Because what Mavenir just said, that's super complicated. We just do the devices.
Okay,
so it's a simple life for us.
That's great. Somebody has to do the job. Any other questions? No? Yes, go on.
Jon, signing for note. Sort of looking back a couple of years, sort of being here even, I think, a couple of years back, it was all about narrowband IoT, would connect all IoT massive devices. And then it shifts to Sigfox and LoRa and other stuff, maybe not in the right order. So what's the main driver for 5G in that sense? To build private networks. I understand it when it comes to the complicated stuff, but if you talk about low value things like your meters you talk about, we connect millions and millions of meters in India, for instance, cost close to nothing with 6LoWPAN, mesh radio networks, chips that cost $2. So what will drive the business in that sense this time compared to the other times?
Well, I don't know. Telia, you might be better to answer that.
Absolutely, I can take it after.
Yeah, because that's a tricky question, because for us, we look at the ones that see something that is critical. Eon and Ellevio both went for the narrowband IoT. They got 1 million smart meter each because they saw that as a critical information that they needed to have, and penetrations and so on and so on. So and therefore, and they also needed the firmware updates backwards into the smart meter, where none of the other really can provide such services. And then, as I said, where are the business models going to be? If ABB thinks that the dustbins and the ventilations and so on, all of it going to be connected, and they think they have business models on that one. Well, sure, then eventually it will come, I suppose. What is that old movie? If you build it, they will come.
And your dreams.
I'm a colleague to Daniel and Contrary.
Yeah.
Just to support Daniel here on business models. I mean, the customers that we're talking about now that is using Narrowband and CapDown for the devices that we are building, industrial companies, they are turning into they have a product business today, but they're turning into a service business. And those devices that they have out in the open is not that compact. They can build their own network as you can in metering. They have a couple of things within any kilometers ahead between them. So they need to have the Telia and the others really reliable networks to be able to deliver the services, which was for earlier products. So I would say that's the real need for this kind of networks today. That you turn the product into a service instead. And then you need a really reliable network. Telia and others, and Telia2 are providing those. And doing that to the lowest possible cost over Narrowband IoT, for instance, is a really good business case for them.
It's going to work in Jämtland and it's going to work in Stockholm.
Yeah.
Yes, we have to stop there. Because we are, thank you so much, Daniel. A great pleasure to have our next speaker, Rachit here, just back from föräldraledighet. Thank you. Welcome.
Jag vet inte, jag försökte förut.
Right. I'm Rachit Saksena. I'm working with Telia as a head of technology for IoT connectivity. I sit within a special business unit called Division X, where all the new revenue business streams are within Telia. And I've been in IoT last 10 years, working with Tele2 IoT and Telenor Connection and the Ericsson previously. So I think it's been an incredible journey so far. I think we're right now at a stage where massive IoT is picking up, like narrowbands and narrowband-based devices. It's always, before we get into the presentation, it's always a device which moves the slowest, the network moves a bit faster, and the cloud moving the fastest. And wherever you can find your business case across these three landscapes, that's what's selling in the market now. But what I'm going to talk about is, from a 5G perspective, how do we explore the other untouched areas when it comes to exposing the full power of 5G? So bear with me. Quick few words about Telia. Those who don't know, it's a service provider for mobile networks across Nordics and Baltics. And we are on a intense 5-year journey for 5G. We have test beds, we have ongoing projects, collaborations, partnerships in the domains of, whether it's industrial automation or gaming or autonomous driving. We're doing sort of all of it. There's a special group in Telia that's looking after, the adoption of 5G, and especially that right now at this moment, use cases that are being pushed into the market are around the massive IoT, which is narrowband LTM kind of use cases, but also private networks into mining, into industrials in Sweden, Norway, Finland are quite industrial countries as well. We have quite a bit of engagement going on when it comes to building up these test beds. And as Annie was quite right, most of the energy, most of the time that we're spending on are building up the business cases, are building up test sites, and really seeing what kind of use cases are really beneficial for the end enterprises, right? Before we, to understand how, from a vision perspective, how we like to deal with 5G, it's important to understand like the 4 corners that we'll talk about that are divided between 2 threads of thought or 2 domains. So one of them is platform as a service or infrastructure as a service providers like Microsoft, Google, Azure. They have quite a big impact on the adoption of 5G and what happens to the developer ecosystem and the application ecosystem that we are all betting on, right? The second one being the comms platform as a service, where companies like Twilio and Sinch with messaging capabilities are able to create new business models, new type of applications all across the world. So From a 5G perspective, the platform as a service providers, they will of course be a important part of the game. They will create general purpose as well as advanced applications working much closer to the mobile network operators. And also mobile network operators, on the other hand, extending their edge compute capabilities into these platform players to create more industry-specific applications, low latency applications. So there's a lot of partnership going on or discussions going on how to evolve this relationship between the mobile network operators and the platform as a service providers, right? So you will see going forward a lot of movement in between and collaboration and customer acquisition as well as in technology acquisition between these two spaces. Right? On the other side, if you look at the comms platform, where the communication is the key. If you look at what Twilio, Sinch, and these companies have done with a handful of APIs that 2G, 3G, or LTE provides over SMS or location tracing or information like that, they have been able to create a massive ecosystem. Messaging is still one of the biggest industries around telcos, right? So when they have been able to create such an advanced ecosystem on a limited set of APIs, 5G will further enable this, right? So we're looking into, we're in a scenario there will be private networks, there will be public networks, but these players or companies like this or innovation centers that come up around, stitching the gaps between mobility between private and public networks, the APIs that comes out of it from 5G will be truly beneficial. So we see there's a big space for CPaaS players to start building their applications and really start finding out, what kind of ecosystems can be built from. And that's a little bit what I'm going to talk about today is, how 5G will enable these different kind of movements that are happening across the cloud, across the mobile operator space, across the communication network or IoT connectivity management platforms. There's a lot of things that comes out of 5G in that space. So in IoT specifically, connectivity management platforms play a very important role. And these are the ones like Cisco Jasper or IoT Accelerator. And they have barely exposed the APIs. It's one network for all kinds of devices, whether it's low power for now or it's been 2G, 3G, LTE devices, the same network. You can't really make an application that works coherently, closely with the network, right? So what 5G will do is it's an old saying that a network is a computer. 5G really opens that door. It creates a programmable network where the landscape around developers, the landscape around cloud providers or connectivity management players or communication management players comes together into crunching those APIs and building an application that ties in very closely to the network. When we've talked about network slicing or private networks or ultra low latency, these will not be a static network or static slice that we will design once and forget. These will be dynamic live networks, controllable depending on the adoption of the devices, depending on the adoption of the application. So it's going to be a mix, and that's what 5G does. It's not only looking into low power, $5 device, but it's a spectrum. It's a spectrum of where you can have low power devices, you can have medium rate devices, or ultra high end devices, all in the same plane, exposing a bunch of APIs that can be controlled easily by when mobile operators tend to expose it. And why will this happen? We're so motivated by wherever we are going, whether it's enterprises or it's partners, everybody's talking about cloud native applications. Okay? So we want to focus a bit more on cloud native IoT. We see, whether it's DevOps in your organization or a few job descriptions like Scrum Master, Agile Coach, everything has changed rapidly in the last 5 years, just because the continuous integration and continuous delivery has become so important, right? Everything in the infrastructure is a code now. So 5G really opens the door where the network can be treated as an infrastructure that can be coded depending on your applications, right? So this is very interesting because now we can start doing collaborations and partnerships and relationships along with the cloud players, along with the device manufacturers, along with the Ericssons and Nokias and Mavenirs of the world, to really see where does the operator play. I mean, are we going to lose 48% of the market to enterprises who will manage their own network, or can this 52% become 75% where we offer, a manageable slices and networks where there's autonomy for the enterprises? So it's an interesting space. There's a lot of collaboration needed. So Things is an important platform to bring together that collaboration, where we can sit down and sketch how we want the network to behave. What kind of APIs are important now? What kind of APIs are really important 2 years down the road, right? So there's a whole planning. I think every mobile operator at this time are rethinking their mobile network architecture, right? So it's a very interesting space to be in. And what will this open up? Like, I mean, we have seen quite a few use cases, and these are not new to you, but like a few key things that come to mind, like on-demand capacity. So it's not like we want to design a slice that will take 2 million meters, right? Because that 2 million meters will not come online on day one, they will grow. So how do we create a network that grows with the capacity needed by the devices? How do we create a network that grows with the the bandwidth usage, right? So on-demand data network selection, like we talked about low latency, but it doesn't have to be a low latency network on day one. It's when the devices are starting to adopt. We still see that low latency devices still 2 to 3 years away in time frame from a mass adoption. IoT has always been this game where when it was 3G was announced, there were no 3G devices. When 4G was announced, there were no 4G devices in the same game here. So there's a lot of it that operators and suppliers like Ericsson or Mavenir we can do together to be able to create a dynamically behaving network that is exposed towards not only cloud players, but towards partners, but also developer communities. This is an exciting space because we can take a piece of infrastructure and investment that has been done and create an ecosystem on top of it in a way that, just like the App Store has done, or Uber has done, or Netflix has done. The infrastructure has always been there, but it was never exposed, right? So now is the chance to expose that network along with a few key players that we can work together to build these kind of use cases, right? So just to summarize, network programmability, this will create a broader range of use cases that we haven't seen so far, but it is something that we can start to work on quite actively, whether we want to sell megabytes to a metering company, or we can give them a slice of the network and say, you want to get a reading 15 minutes, here's your slice of network, and here's the SLA, go do it. And really changing the business model from going from megabit pricing to the number of API calls that they're done. That's where the industry, I think, will move forward. Right? Thank you.
Great, thank you, Rachit. Question. This is your time.
I have one. Even that is a talking about 5G from your point of view as a care operator, going to parallels with cloud usage. 2D, 3D, 4D was completely driven by the consumer market and the handsets. Agree?
Absolutely, yeah.
So what's driving this? What's the market driving?
Well, if you look at the 3GPP standardization that has gone into to create the 5G standards, it hasn't only been the consumer companies, it hasn't only been the Apples and the Samsung. There's Schneider, there is Siemens, there are all kinds of industrial manufacturers have sat down across the table and said, hey, we want machine-type communication, we want low latency communication. The truck manufacturers are there, or the light bulb manufacturers are there, Philips is there. So what's really driving, what will drive the adoption is that the standard say it's available in the network. So the consumer or the enterprise, who's our basically IoT's customer, is going to come, if these things are in the standard, you know, why don't you expose these APIs to me? Because previously we could have said, we can't open the network for you. Now the standards have been designed the other way around to make sure that these use cases, if not addressed now, are addressed between 2 to 5 years of time.
Disagree. Of course, all these companies that you mentioned, they will build their own data networks. And we will care about that. And then we use the own network as the industrial drivers. It's not consumer drivers, no handset drivers, and there's not many sensor drivers. It's a complete infrastructure manufacturing facilities, as you mentioned. And they will build their own networks.
Well, it's okay to disagree, but I don't have the list of all the companies that have sat across the table and designed those APIs. But if you look at the API specification for machine-type communication, on top of latency communication, all these use cases, the ARs, the VRs, the robotics, the drones, they have been there, and there have been test beds proving that these applications are possible.
So I ask one question, what's your point of view as a telco?
I mean, we want to work closely with everybody, making sure that even if there's a need for creating a private network, I mean, we are good at managing networks, so that's what we will do. We will try to, I mean, there's a huge team in Telia who's trying to sell private networks and take a managed services contract. So there's, as long as, you know, there's money at the end of it and there's innovation at the head of it, I think things will happen.
Good, more questions?
Right, thank you so much.
Well, thank you so much for this. I was desperately looking for somebody who can show us in real life what the meaning of low latency is in terms of application. So, and I got to think about things who've been there for many years in the building. At the time called My Music Labs, these days they're called ELK. And Stefano, I'm so happy to have you here. Can you just please share some light of what you are doing and why 5G is even in your territory? Take it away.
Absolutely. Thank you, Magnus. And it's really great to be here again, because I'm literally feeling at home, because Things was our first home, our first office as a startup. And we had a great time here. It was so important for the early days of our companies. So I will talk here about a concrete use case of what low latency can be for some application, and it has to do with music and the audio. But before going into a quick overview, let me just speak about the problem. Everyone these days, especially these days, is used to have a video chat over Zoom, Skype, and probably we're spending most of our days over Zoom. And it works well if you're just speaking one at a time. But when you're going to play music together, the requirements for the network connectivity and latency are orders of magnitude tighter. I mean, I was speaking with a friend of mine. He was mentioning that during one work meetings over Zoom, there was one of them, it was his birthday. So they say, oh, let's sing a happy birthday. And they try to sing happy birthday over Zoom. And the result was terrible. I mean, if you want to try a very simple experiment, next time you're going to have a video chat, just try to clap your hands together. And you will realize how it's basically impossible with current technologies. So Aloha is our solution designed for making musicians play together in real time, like they're in the same room. And before speaking much more, I will just show you a quick teaser video that should get you an idea.
Zoom share.
Oh,
If you click on that.
oh, resume share. Okay, thank you. And now I guess I need to do like this. Okay, yeah. And oh, but can I click the link? Oh yeah, it's opening up. We're not, I'm sorry, we're not getting audio. I guess we just need to. Oh, so the audio is coming from the laptop speaker, or because we don't have a. Okay. I hope it's loud enough for you to hear. Yeah, let's try. Otherwise, there are going to be links on our website, so you can find everything there. Right.
Wow.
Thank you. So let's see if I can resume this. Okay. So first, a little bit of history, just to see who we are and how we came to be here with Aloha. So as a company, our name is ELK, formerly Mind Music Labs, and our core product is an system for embedded IoT devices, designed specifically for audio products. So in other words, what we have is a Linux distribution for kind of and many different embedded CPUs. And one of the key advantages of our system is that we can run audio in real time with order of magnitude lower latency than normal Linux distribution for embedded. So typically, like your normal Linux distribution on, let's say, Raspberry Pi or 9x810, it's going to give you like 20 millisecond audio round trip loop back. We can get to 1 instead of 20, and still keeping all the advantages of the system. And that's one part of the story. And we're able to achieve that with a particular combination of a real-time operating system kernel running together in the same CPU with a Linux kernel. The other part of the story is that we designed the system to be extremely friendly for developers since the beginning. And here you see a lot of labels, DST, RE, MIDI, LV2. They're all existing standards, because one of our core beliefs was that we didn't want to invent new standards. We just worked hard to take existing standards that were already there for desktop computers, mobile, and we made them work in our embedded IoT devices. So we take basically software, music software, it was written originally for a computer. You just click a button, you recompile it, and it takes advantage of the magic of our real-time system without the developer having to do anything on top of it. And we have ELK is also open source with dual license, so you can go to our GitHub pages and download all of it, customize it to your own need, try it out yourself. Aloha is basically the end of a story that we started a couple of years ago, almost, with initially with Ericsson. So we partnered with Ericsson. They had an internal project in their garage for startups. It was called Music Connect. And they wanted to, be one of the first to try low latency audio over the experimental 5G test that they had in-house. And so they were looking for a platform, and we met and say, okay, ELK seems the best way to realize this. So we worked together, and Mobile Congress Barcelona last year, we had this very nice setup where they had like a band split in 2 parts. One part was at the Ericsson booth, the other part was at the Vodafone booth, and they were like, I don't know, like 3 kilometers apart, and they were just playing together over this experimental 5G test there during the event. And that was fine. And after that, Ericsson organized a lot of events like these on both private and even public 5G networks all around the world, like Thailand, Spain, India. It was pretty successful. In the meanwhile, we internally, we started to re-engineer the solution for our own internal use. That's when Aloha started, like end of 2019. But still, the plan was that we wanted to do something for when 5G will be ready and mature enough, like 2021, 22. And then COVID came this year. So it came when we just started this development, we said, well, so immediately all the musicians had a need. There are no live concerts. They are not able to rehearse together. So we just meet together and say, what can we do? And so we decided to do something right now to help the musicians. And so we are testing and deploying to a group of closed beta testers this solution that today runs on your normal fiber internet. We designed a pretty cheap hardware. We are not hardware manufacturers, but we are good hardware prototypers. So we designed our own small shield, and there's currently a small number of musicians, which is growing, that is testing and trying. They're having a lot of fun. Just the other day, I couldn't believe, but someone told me that they were playing between Stockholm and Madrid on their normal home network. And they say, it feels like we're in the same room. And these guys were pretty high professional musicians, so they have quite high requirements. And yeah, so that's the current story. We're in a closed beta phase, and we have plans for 2021 to actually release a commercial product for use on your own home fixed network. Very quickly, and just to give you like an idea, it's a full ecosystem where there are many different parts and pieces of software running in various places. So we have our own device, our hardware, where we run the real-time streaming, the components. There are some backend parts that communicate. There's a GUI application that users run on their laptops or mobile phones. It's web-based. So you need another device to actually control. And the interface is pretty much like Skype. You choose who you want to talk with. You just say, let's call, and then you have some controls like node application, faders, and paths. And then finally, there's of course some services running on the cloud that help to orchestrate everything. There are similar things that more or less work, but we benchmark and we run comparison. We believe and we demonstrate we are currently better than anything else by a significant factor. And the reasons are, first, because no one else is using audio OS, such a real-time operating system, to run this kind of audio, low latency audio streaming. That's the first advantage that we have. Second, we can take care of not only doing real-time audio, but also very strict real-time networking on the embedded device. And then we added like a good implementation of a few things that you need in this context. For example, we have an error concealment, which is way more advanced than what you have in Skype. This means that you will have dropped packets. When you miss a packet, we have an algorithm that basically reconstructs, try to guess the content of the packet so that the musician don't hear the result. And then we have this pretty accurate time synchronization mechanism so that players can share a metronome and play in sync together with each other. So what about 5G? So we are, I mean, it's not there yet, but we're still working on 5G. We have a partnership with Ericsson, Vodafone, and Verizon. And we are currently, always being tested by these telco operators on the real 5G networks. And at the same time, we're doing a lot of simulation and design architecture for what will be a 5G deployment, probably around 2022. Hard to predict now. The advantages that we see in 5G are, well, first it's going to be wireless and portable, because right now users have to physically connect an RJ45 cable to their routers. And then, I mean, what we saw before, all this network slicing and quality of service guarantee, it basically will give us something that we don't have control over the normal internet. We can ask the operator to say, hey, please give us priority to our real-time jamming over the person that are watching Netflix. And finally, I mean, a great thing about 5G is that it's a fresh start in laying out the network. I mean, it's not just what is technically possible, but it's just that today's internet that it is deployed, it has to maintain so much backward compatibility, you cannot change things around. Well, it is possible with a new design such as 5G. The challenges and the reason it's going to take a while to get there is that we will need quite a wide deployment for this to be commercially viable. We will need to have the 5G core pieces deployed everywhere, which is just starting to appear, and also the ultra reliable low latency connectivity for the best experience. Then on our devices, we will also need some reasonably low cost modems, which are not there yet in the price range that we need, but they will likely appear in the next years. And finally, we'll need to set up an architecture to have orchestration with MTEK, the mobile edge computing. And regarding this last point, just a couple of diagrams to show you what's the difference. So what we are having today over fixed network is a complete peer-to-peer solution, which we nickname Aloha Band, because it scales up to more or less 4 or 5 players. And all the devices are connected in a full mesh configuration. Everyone talks with each other. So you have pretty low latency, but it doesn't scale to many musicians. What we will have for 5G is we will take advantage of all the user equipment connected to a single base station. And there we can run our virtual orchestra director, which is basically a piece of software that coordinates the players and does the audio mixing. And the great thing is that it could run on a server that is directly there. So we're going to be able to handle way more users at the same time without adding a significant amount of latency. And then finally, when you have many users that are spread across various locations, we will have quite a combination of the two things. So we'll have different base stations and a different set of users connected to each base station. And then the base station, the MTEKs, are going to be connected in a mesh between each other. Okay, that was pretty much the end of my presentation. I'm of course happy to share some comments, but I would like to show you another like a couple of minutes of videos. And these are actually all live performances that have been done with Aloha in various parts of the world. The first one, this guy, for those who you recognize, is Nils Lindgren, who actually was one of the first testers for this remote jam session between Skåne and Stockholm that he did with his drummer here for jazz festival, virtual jazz festival. They were the only one doing it for real. All the other people in this jazz festival, they were recording one track at a time. First I record the drums, then I send you the drum track and you play on top. And we were the only one making it up, and actually they are playing at the same time with extremely low latency. And all the others are just various cool examples that we are shooting and adding to our. Video buffering. Let me see if we can just. To go in it, but when I do, there is no doubt it's gonna be a crazy night.
I'm just having fun. Don't get in a fight. You stay in the lane, just don't get in. And when you do, and all begins, you never win, and you never lose. And in the end, you don't get to choose. Well, it goes like this: the fourth, the fifth, the minor fall, the major lift, the baffled king composing hallelujah.
All right.
Great, thank you.
Thank
Stefano.
you.
Do we have any questions on this? What is there more to say? How much it costs?
Exactly. When are we going to get a reconstruct back? No, but what's the longest latency that could be accepted in this? You know, could you live for 100 milliseconds, or is it 20 or?
That's a great question, and if you ask different musicians, depending on you know, if they are professional, amateur, what kind of instruments and what genre of music you're playing, you will get different answers. So if you're singing, I don't know, Gregorian in a Gregorian choir, then you can tolerate pretty high latency. But if you're doing like jazz fusion, like Nils Lindgren and his drummer, then you need very low. The magic number that we use as an average for these professional musician use cases are like 20 millisecond analog audio to analog audio one way total latency. So that's not just the network, but also the other conversion part. That's the magic number we assume. If you stay below that number, then you can give the impression that you're feeling that you're playing in the same room.
Cool. So when are you going to make our video conferences reasonable?
That's the video part. We're not going to solve it, unfortunately.
No,
but
we
we do have some interest. We are discussing with some companies that they believe that this could be useful for high quality teleconferencing. We actually tried this just to speak over Aloha, and it feels great because the audio quality is nice. You can suddenly, just do this small intermission between each other. Let's say, hey, yes. So we do believe that there might be a market to set like corporate business on good quality. Yeah. There was another question over there.
Yeah, it was pretty much the same question about the singing together in the conferences. If you could like take a couple of streams in and do the synchronization with the incoming voices, and then bring them back in one chunk, so you actually get some kind of choiring.
That's something we are kind of doing. So we're working now on this live broadcast feature. So when the musicians see the video when they're playing Aloha, for them the video is out of sync with the audio. Just use the video to talk to each other, get some visual clue at the beginning of a song. But then when they want to stream a concert to an audience, basically everything gets synced up using timestamps and the SMT standard. So then the final audience will see everything that is lip synced perfectly. But of course, the final audience are going to receive the stream like 1 second later or something like that.
To do it today, if you're playing like three musicians together, you have to keep the beat in the
transition.
So if they have latency, too much latency in their networks,
then you won't receive one of the musicians. You just remove it from the output, or how do you handle it?
Well, every incoming stream has a different. There's of course some buffering,
Yeah.
and so if
20 milliseconds.
no, it depends. I mean, you can set it, and it also dynamically adjusted. So if I'm playing with you and Magnus, we're playing together, and Magnus has some bad connectivity that coming from my side. I'm sorry, but so what they can have in that case, I will add that his stream will be buffered more, and your stream will be buffered less. And then there's also the option if I want to hear everything just delayed, or you can just hear his stream later, because let's say you're the drummer, I want to hear you very fast, but maybe he's the singer, so I don't care that much if the kick comes at the same time. So then it's up to the user to have these final adjustments.
When you set the acceptable latency, then if you don't get one of the voices, you remove it. Because you can shift the latency, then you will get you will lose the beat in that.
I
I
think you have to take that discussion.
Oh, okay. Sorry.
The last question from Mats.
Same boring question. How will you sell it? What's the business model? Subscription?
That's a great question. I'm the tech nerd. I code things. I like it. I just am happy that it works. So
you give it away.
I should put you in contact with our guys, business guys. But basically, so the user will get a device, and we're looking a lot into the education market because we've been literally contacted by many music schools. We have a project with Chemical here right now, funded by Vinnova. And so the user will buy a device, that's part of the business. And then the other big part of the business is a subscription model where you can get.
That's the last part I want to hear.
Okay.
So I think we stop there, but before I let you go, you have to answer the question. So what happened to your Sensus guitar?
Oh, the Sensus guitar.
Remember the Sensus guitar. If you didn't, you have to go to the internet and take a look.
That's that was our first product. As we said, it was our journey to the moon. So it was never our final goal. And what happened is that we realized quite soon there was more interest in the technology behind the guitar than the guitar itself. So that's basically what how Apple was born. Apple was the foundation, the technology behind the guitar.
But the Muse guitarist, what
yeah,
did they use?
We also had 1 year ago, we had this nice success story. We met with the Muse, Matt Bellamy, guitar tech people, and we were able, thanks to iCodeOS, to make a very special guitar for him in literally 2 weeks, because for the world tour that they did worldwide, it was like a unique piece. Yeah, but the thing that we are most proud of is not just the end result, but we literally managed to do something that was ready for world stage in 2 weeks. That was quite an accomplishment.
That's good. That's great. You're a great company, so thank you so much.
Thank you.